This is so in this video we are looking at the normal distribution. So the normal distribution is one of the most frequently used probability distributions, and it models continuous functions such as height and weight. Now it has a bell-shaped curve, so if we were to draw the curve, it looks a little bit like this. Now in this curve, what you have is you have the mean down here. Now this is equal to the mean, which is roughly equal to the mode and the median as well. You also have in it a symmetrical, it is also symmetrical, the distribution of it is symmetrical, so this will come in very useful later when we start looking at things like inverse, the inverse of a normal distribution. Then 68% of the values lie within one standard deviation of the mean, so you could say that one standard deviation there, that's 68% of values will lie within that area here. So that area there is going to be around 68%. And then what you have is 99.8% of the values, so around there, will lie within 3 standard deviations of the mean. So that is the general idea of the normal distribution. So in our first question, it says that the distribution of weights of coffee in a jar is normally distributed with a mean of 200 grams and a standard deviation of 4.2 grams. So therefore, if we were to show this, we would say that weight is normally distributed, and then we have a mean of 200 and a standard deviation of 4.2. And we put 4.2 squared because that is the variance, but the 4.2 is what we're going to need, but we do put variance there. Now then, it says that find the probability that the weight of a coffee is more than 205 grams. So we're going to go to our distribution sectors on our calculator, and we're going to use normal CD. Now, there is actually no real need to use normal PD for anything, as you can do everything you need with either normal CD or inverse normal. So therefore, for normal CD, what we're going to say, if it's more than 205 grams, we're going to say that our lower bound is going to equal 205. Then our upper bound, now this can basically be any number that is extremely high. Officially, if it's 5 standard deviations higher, then it will definitely be in the range, but what we'll say is, we'll just say for this case, we'll just say 10,000. So just a very high number. It doesn't have to be a specific number as long as it's way above that 5 standard deviation mark. Then if we do our standard deviation, in this case that's 4.2, and then our mean is going to be equal to 200. Then just press equals on your calculator, and therefore what we're going to get is the probability is equal to 0.1169. Now if we look at B, we're going to be using normal CD again. This time though, it's asking for less than 195. That means our lower bound is going to be something extremely low. So let's say minus 1,000, for example. Then upper bound, now this time that's going to be 195, because that's the upper bound. Is going to be less than it. When it's less than, our upper bound is going to be that number. Then standard deviation is going to be 4.2, and the mean is going to be 200. Therefore, using our calculator to press equal, we're also going to get P is equal to 0.1169, which could show the symmetry of our normal curve. So final one is asking for between 195 grams and 205 grams. Again, we're going to be using this normal CD. Lower bound is going to be 195 this time. Upper bound is going to be 205. So we're looking at what's going to be between. Then this is going to stay the same. That's equal to 4.2. And then mean is going to be 200. Therefore, this time, the probability is going to be 0.7661. Now, if you were to look at it on a normal curve, for example, this is our bell-shaped curve here. then if we were looking at, say, 195 there, and say 205 there, you go up there, you're going to go up here, but the area we've just worked out this area here. So that is the area of 0.7661, and that is the area because on a continuous function, the area beneath is the probability. So this is a very similar question, so just pause the video and have a go if you want to, because what we're going to use for this one is, again, normal CD, and this time what we have is we have a lower bound of 340, then we have an upper bound of 370. Now this is because it says that it's got a volume between 340 milliliters and 370 milliliters, and therefore we just need to look at our standard deviation. It says we've got a standard deviation of 12, and then our mean, which is going to be 350. So if we were to write this in our thing, we would say coffee, we could put C, is normally distributed, and then we would have our mean 350 and then our standard deviation squared. So that is what it would look like if we didn't have it written out like that. So therefore now we just need to type that into our calculator, and therefore what we get is the probability is equal on 0.7499. So in the next question, we're going to introduce the idea of the inverse normal, which is using the idea of areas. So first of all, to this question, which we'll draw a bell-shaped curve to show exactly what is going on. Now, if we can see, it says that the variable x is normally distributed. It says that x is less than 52 is equal to 0.2. So that means if we said that that's 52 there, we're saying that the area of that, this shaded area here, is going to be 0.2. So that area there is 0.2. We are also saying that x is more than 60, which we could say if that's 52 there. If, say, 60 was around here, then that area of there is going to be 0.3. So that area there is 0.3 if that is 60 there. We can also say for this one, to change it around, because of its symmetry, we can say that less than 60 then is going to be all of this, which is going to be, so that plus all of that, that's going to be 0.7, and that is equal to 1 minus 0.3. So therefore, what we're going to say then is we'll start off by using this standard normal. And the standard normal we say is going to be z is going to be equal to x minus the mean over the standard deviation. And that is what we call our standard normal. Now in this case, we're going to say that the mean is going to be equal to 0, and then standard deviation is equal to 1. So therefore, if we start off by using this, we're going to say then that z, the area for the for x is less than 52 is going to be equal to 0.2. So that means that we're using on our inverse normal, we're typing in that the area is 0.2, then the standard deviation is equal to 1, mean is equal to 0, that is equal, therefore, to minus 0.8416. So therefore, now we have that number, we can use that to say that that is our z value. Now we have our z value. So now we have our z value, we can say that minus 0.8416 is going to be equal to x, which in this case is 52, then minus the mean, which we're trying to find out. We're trying to find out the mean and the standard deviation, divided by the standard deviation. Now, on the other hand, now we need to look at the x is more than 60. And for this one, we're actually going to say that the area is going to be 0.7, and we're going to change it around this time. Instead of x is more than 60, we'll say that x is now less than 60 is equal to 0.7. And that is what we need for questions like this. So therefore, the standard deviation is going to be 1 again, and then the mean is going to be 0. That is therefore equal, if we type it in on our inverse normal, we're going to get an answer of 0.5244 is equal to 60 minus mean over standard deviation. So now we've got these two here. These are our two that we're going to need. And now we're going to use simultaneous equations in order to cancel one of them to get the other. So that means that we can times both of them by its standard deviation. That means we're going to get minus 0.8416 is going to be, and that's times by this standard deviation. It's going to be equal to 52 minus the mean. And then what we'll do actually is we'll put this one on top so that we can get our full answer. That's going to be 0.5244 times by the standard deviation, and that's equal to 60 minus the mean. Then we can minus this one from that one. So that means that if we minus this one for that one, we're going to get rid of those means, which are going to minus, there's technically going to be the minus mean and then plus a mean. So that is therefore going to be equal to 1.366. Standard deviation is going to be equal to 8. Therefore, the standard deviation of this is going to be equal to 5.857. Now we have our unknown. All we have to do now is work out the mean, and we can just stick that back into one of these here. So for example, we'll stick it back into the first one here, and the mean is going to be equal, therefore, to 60 minus, that's going to be 0.5244 times by the standard deviation, which you've just worked out, 5.857. Therefore, the mean is going to be equal to 56.929. So that's our mean there. And our standard deviation is that. So that's how you work it out using the inverse normal. So the next question is also using this idea of the inverse normal. And this one says that the 100-meter race times an athlete records are normally distributed. So 16% of the time, the athlete is faster than 10 seconds. Now, if we are writing that, that means that the probability of x is going to be less than 10. Faster, it's going to be less than 10. He does it in under 10 seconds. And that's going to be equal to the area of 0.16. Now we can also say that 23% of the time that athlete is slower than 11 seconds. So in this case, we're going to see that the probability that x is more than 11 this time is equal to 0.23. Now again, we'll show this on a bell-shaped curve to see exactly what's going on. So we're saying that 10, less than 10, we've got around here, say, and we'll say it's around that. Now that is therefore 10. This here, area here, is going to be 0.16. In this case, if it's more than 11, so if we had 11, say here, now this area here is going to be 0.23. That also means that the probability that x is less than 11 is going to be equal to 1 minus 0.23, and that is equal to 0.77. And that is the one we'll be using. We're always going to be using that x is less than 11, and if it's more than, we're going to be changing it around. So therefore, we'll start off by working using this one here, using our inverse normal, remembering to put it as 1 and 0. Our standard deviation is 1, our mean as 0, because it's standardized. We're standardizing everything in this. So therefore, we're going to let the area equal 0.16. Then the standard deviation is going to be 1 and the mean equals 0. Therefore, that means that z is going to be equal, in this case, to minus 99446. That's minus 0.99446. And therefore, we can say that minus 0.99446 is going to be equal to 10, because that's what our x is there. X is 10 minus, and then it's going to be minus mean, and then over the standard deviation. So we've got that, and now we can find out what it's going to be when it's 11. So therefore, allowing 11, let area equal 0.77. So therefore, standard deviation is going to be 1 again. The mean is going to be 0. Therefore, put that into your calculator, and this time z is going to be equal to 0.73885. So therefore, what we're going to have here is 0.73885, and that is equal to 11 minus the mean divided by the standard deviation. So now we've got these two simultaneous equations here, which we can use, as we did in the last question, to find out what the mean and the standard deviation are. So therefore, times everything by the standard deviation, and that means that we're going to get minus 0. We'll start off actually with the 0.7, so we'll get 0.73885 times by the standard deviation is equal to 11 minus the mean, and then we're also going to get minus 0.99446 times by the standard deviation is equal to 10 minus the mean. Therefore, we'll minus that one there, and that shall give us 1.7333 times by the standard deviation, and that is going to be equal, therefore, to 1. 11 minus 10. Therefore, a standard deviation in this one is going to be 0.577. So now we have our standard deviation. All we need to do is pop that back in to get our mean. So then we're going to use this one here. We'll use 11. It's going to be minus 0.73885 times by 0.577. That's equal, that's the mean is equal to that, which is also equal to 10.574. So the final question we have here is all about 2 mills producing bags of flour. And it says that mill A produces bags with mass X kilograms, and then that is distributed normally with a mean of 1.2 and a standard deviation of 0.05. And then mill B produces bags with mass, again it's normally distributed, 1.3 is the mean and 0.1 is the standard deviation. So A and B, so AI and then II, those two are both about using the ideas that we looked at in the first questions we had today. So if we look at I, what we're going to have is calculate the probability that a randomly chosen bag has mass more than 1.25. Now if it's more than 1.25, therefore our lower bound is going to be equal to 1.25, and then our upper bound is going to be equal to, say, 1,000. Again, can be any very large number. Then in this, our mean is going to be our sort of standard deviation, sorry, is going to be our 0.05, and then our mean is going to be 1.2. Therefore, the probability is equal to 0.15866. So therefore, if we look at II now, we're going to get a similar question. It's just asking for mill B, and it's asking for a mass more than 1.4. So this time, all we're going to change is the lower bound, and then obviously the means and the standard deviation. So the lower bound is going to be 1.4 this time. Upper bound we can keep the same as 1,000. Then the standard deviation, this time it's going to be 0.1, and the mean is going to be 1.3. Now this has exactly the same probability as 0.15866. So therefore, the next question is asking us to show that for W, which is normally distributed, and then in terms of mean and then variance there with standard deviation, the probability of W taking a value more than one standard deviation above the mean is 0.1587, which is the same as the answers we just have got there. So therefore, for this question, what we're going to have is we're going to say that the probability that W, and it says more than, and then it's going to be mean plus standard deviation. It says that one standard deviation above the mean could be 0.1587. Now that is therefore equal to the probability that Z is going to be more than, and if you remember, X in this case is going to be the mean plus the standard deviation. Then it's going to be minus the mean, and this is just using that standardized normal. Remember, X minus mean over the standard deviation. That's over the standard deviation there. Now this one, what we can do is these are going to cancel. These are also going to cancel as such, which means it's probability that Z is more than 1. So therefore, we can say that our lower bound is equal to 1. Our upper bound can be equal to 1,000 we'll use again. Then we can say that we'll just standardize this, so our standard deviation is going to be 1, and then the mean is 0, and therefore probability is equal to 0.1587, as it says for us to find. Then in part 4, it says that show that W, when W is normally distributed in terms of a mean and then standard deviation, the probability of W taking a value more than n standard deviations below the mean is P. The probability is that Z is less than minus n. So in this case, what we have is the probability of W being less than, and then it's going to be the mean minus n times by standard deviation this time, because standard deviation is n standard deviations. Therefore, that is equal to a probability that Z is going to be less than, and then we have the mean minus n standard deviations, that's our x, minus the mean, and then that's all over standard deviation. Have that, then what we can have, these are again going to cancel, so then we're just left with, that's going to cancel there, so therefore probability that z is less than minus n, which is what it wants in the question. Final one we have now is B. We're looking at B, and it says that the two males are equally likely to produce a bag of mass less than a kg. Find A. So in order to do this, we're going to be using this idea which we've used all out of the z, and then the idea that it's going to be x minus the mean over the standard deviation, and we're going to say that the probability that x is less than a, and that's going to be our x. So therefore, if we take a first of all, we're using milli, that is going to equal a minus, and then it's going to be 1.2, because that's our mean, divided by the standard deviation, which is 0.05. Then b is going to be a, then minus 1.3, divided by 0.1. So what we're saying now is that those two are equal to each other. So A is equal to B. Therefore, we can times everything by 0.05 and times everything by 0.1. That will give us 0.05 times by A minus 1.3 is going to be equal to 0.1, and then it will be A minus 1.2. So therefore, we can start substituting. We'll put the 0.05 in, and that will give us 0.05A, and then that will be then minus 0.065 is equal to 0.1A minus 0.12. Therefore, doing some rearranging, we're going to get that 0.05A is equal to 0.055. Therefore, A is equal to 1.1, and that is our value of A. So thank you for watching this video about the normal distribution. Hopefully it's been useful. So see you soon. Bye.